Hey guys, it's Jacqueline, and today we're going to do a lesson on solving equations. So first, you might ask yourself, what are equations? So here are some examples of what different equations can look like. We've got 4x plus 7, 9x minus 3, 5x minus 2, x squared minus 4x plus 4, and 2x squared plus 2x plus 2. As you can see, equations come in all different shapes and sizes, and today we're going to be working with these 5, and I'm going to teach you how to be able to solve them. So we're going to look at the equation 4x plus 7 first. So for this equation here, we're going to take the approach of plugging in. So sometimes when you're given an equation, you're also given a value for your variable. Here, our variable is x. So say x is 2. So when x is 2, we plug 2 in here. So we should put our numbers in parentheses to denote multiplication. So we're going to have our 4 times 2 plus 7. So now we're just going to simplify. 4 times 2 is 8. So we have 8 plus 7. And 8 plus 7 is 15. So you can see when we were given a value for our variable, which in this case was x equals 2, it's very simple to solve the equation. You just plug in your x wherever you see an x and then simplify. So next we're going to look at the equation 9x minus 3. When you're not given a value for x to solve an equation, you set it equal to 0. So that's what we're going to do here with our 9x minus 3. And when you're solving an equation, you must solve for the variable. And our variable in this equation is also x. So, how do you solve an equation? You want to isolate the variable. So, we have to get rid of everything else that is not the x. So we're going to start with this 3 here. And we're going to want it on the other side to get it away from the x, because we want x alone. So if you want to get rid of a minus 3, you're going to add 3. But since this is an equation, both sides have to stay equal at all times. So we're going to add the 3 to the right side of the equal sign as well. So that's going to leave us with 9x. Now these 3's cancel, is equal to 0 plus 3 is 3. So 9x equals 3. But we're not quite done yet, because our x isn't alone. So what do we have to do? Well, if you want to get rid of the 9, to undo multiplication, you divide. So we're going to divide this side by the 9, because now these 9's cancel. But we're going to divide the other side by 9 as well, because it's an equation, and we have to keep it equal. So we're just going to go over here and rewrite our equation all cleaned up. As you can see, we have our x by itself. And now we have x equals 3/9. But we can simplify this, because 3 divided by 9 can be simplified into 1/3. So the next equation we're going to solve is 5x minus 2. 5x minus 2 has the same basic form as our last equation, 9x minus 3. Where we have one x variable right here. So we're going to go ahead and do the same steps as before. We're going to set it equal to 0. And we're going to try and get x alone. So we're going to move this 2 on over. To get rid of that, we're going to add 2. And then these 2's are going to cancel. We got to keep things equal. So we got to add 2 to the other side as well. So then that leaves us with 5x on this side And the minus 2 is gone now because we canceled it out. And then we're left with a 0 plus 2, which is 2 on the other side. Our x is still not alone, so we're going to have to get rid of our 5. So what do we do to get rid of something we multiply by? We divide by the same thing. So we're going to divide by a 5 on this side, and then our 5s are going to cancel. And then we're going to divide by 5 on the other side as well, so that we keep everything equal. That's going to leave our x by itself, just like we wanted. And then on the other side, we're going to have equal to 2/5. So here, when we solve for x, we get 2/5. And the next equation we're going to talk about looks a little different than the last two. We're going to look at this one. It's going to be x squared minus 4x plus 4. And what do you notice that's different about this one than the other ones? We've got our variable x in more than one location. So what does that mean for us? Well, we're going to talk about factoring. So factoring is a technique that we use to solve equations when we don't have just one x. So we're going to keep our first step the same. We're going to set this equal to 0. Second step when factoring is to see if you have any like terms, any constant numbers you could pull out of the equation. In this case, we don't have that because you would have to have 4s or 2s or anything like that across the board. But our x squared variable here does not have a 2 or a 4, so we cannot pull anything out ahead of time. The next step is to set up two sets of parentheses, because parentheses imply multiplication. Now when you're factoring, you need to split the equation into two different things that can be multiplied to give you your original equation. We do this so that we can isolate x. So, to get x squared, you have to multiply x times x. So we're going to put an x in the first pair of parentheses and an x also in the second pair of parentheses. Because when you expand or multiply two sets of parentheses that have more than one term in them, you multiply the first two terms together first, and that'll give you your original x squared. Now we're going to look at the last term. So the last term is a 4. So what are some ways that you can what are some numbers you can multiply together to get 4? Well, the first thing that comes to my mind is 2 times 2. There's also the option of 1 times 4, but that's not going to work out for this equation. We could try it, but we would not get the correct middle term if we did that. And I could show you the math for that in a second. But we're going to go through with this one. So the rules are when there's a plus sign on the last term of an equation with a square, that means that both signs between the x and the number in the brackets are going to be the same. And when that's the case, we look at our middle term, and whatever sign is there, that's the sign we're going to use in both our brackets. When the last term has a negative sign, that means that both of the signs are going to be different, not the same like when we have a positive. And then it's just trial and error to see which one you would need. So now to make sure that we factored correctly, we're just going to go ahead and multiply these two out and see if we get our original. When you factor, to get back to your original equation, we use the acronym FOIL. This stands for first, outer, inner, and last. And what that represents is you do the first two terms, you multiply them, then you multiply the two outer terms, the x and the negative 2, from here and here. The two inner terms would be this negative 2 and this x, and the last terms, negative 2 with the negative 2. So when you do that, you do in fact get back to our original equation, because x times x gives x squared. X times negative 2 is negative 2x. negative 2 times x is also negative 2x, which can be combined to give negative 4x, like in our original, and negative 2 times negative 2 gives a positive 4. So we know we've done our math right when we get our original equation back. We put it into this form so we can set each set of parentheses equal to 0 separately. So now we can isolate x. We're going to end up only getting one solution because our two terms are the same, but we'll write both of them out anyhow. So we have x minus 2 equal to 0 for both parentheses. And then, just like our old equations, we're going to try and isolate x. So we're going to add 2 to this side. The 2's will cancel. We're going to add 2 to this side. So then we get x by itself equal to 0 plus 2, which is just 2. And we get the same thing over here. We add the 2 to both sides. We get x equal to 2. So our only solution for this problem is x equal to 2. We just get it twice, which doesn't change the answer. So now we're going to look at our last equation. This one is 2x squared plus 2x plus 2. So our first step is always to set equal to 0 when we're solving equations. Now, the first step when doing binomials is to see if you can pull something out. In our last equation, we did not. There was nothing we could pull out. But here, in each term, there is a 2 in common. What I mean by that is you could write this as 2 times x squared plus 2 times x. Over here, the 2 can be rewritten as plus 2 times 1 and have that set equal to 0. So now what we do, since they're all multiplied by 2, our 2x squared, our 2x, and our 2, we pull the 2 out to the outside and multiply by everything that's left. So we're still multiplying x squared by 2. We're still multiplying x by 2. And we are still multiplying 1 by 2. And we're still all equal to 0. And this step is really helpful for us because now we can just ignore this 2. Because when you want to isolate for x, you want to get rid of everything else. And when you want to get rid of a multiplied number, you divide by it. And 0 divided by 2 is just 0. So we can divide by our 2. These 2 cancel. Divide 0 by 2 and still get 0. So we're going to rewrite our equation down over here. We've got x squared plus x plus 1 equal to 0. And now we've got to set up like our last problem. So we're going to set up our pair of parentheses. Since we just have x squared, we're going to put an x in the front of each pair of parentheses. Because x times x is x squared. So now we're going to look at our last term, and the sign is positive. The sign is positive. So when the sign is positive, we have the same sign in both sets of parentheses. And now we check our middle term. And this is also positive. So that's telling us if we're going to be using the factoring method, that we need to have pluses in both parentheses. And the only way to get 1 is multiplying it by itself, 1 by 1. But as you can see, if we were to FOIL this out, we would not, in fact, be getting our original equation. We would get x squared plus an x plus 1. But that gives us x squared plus 2x plus 1. So that lets us know that this approach will not work. So we're going to get rid of this work and approach it a different way. So now that we've got some more room to work with, we're going to look this in a different way. So now we're going to try and isolate the x. It's going to be a little different, but we're going to try anyway. So we're going to get rid of this one. We're going to move it on over. We'll see if that's going to help us out. So we subtract a 1 from both sides, and these ones cancel. So then that leaves us with x squared plus x equal to negative 1. So now we see, do we have anything in common maybe that we could pull out that would help us? And we do. We have x, because x squared can be written as x times x, and x can be written as x times 1. So we're going to do something similar to what we did up here, but I'm not going to write all the steps out this time. We're going to put the x outside, and then we're left with x plus 1 on the inside, because x squared is just x times x, and x is x times 1. And this is all equal to negative 1. So we're going to have 2 different answers. We've got this x here that's going to be equal to negative 1. And then we've got our x plus 1, which is also equal to negative 1. So we're going to circle this one and leave it for later. That's one of our solutions. And then we're just going to finish solving this one. So we're going to subtract the 1 from both sides. These ones cancel, and we're left with x equals negative 2, because negative 1 minus 1 is negative 2. And that is our second answer. And that's going to conclude our lesson on how to solve equations. So now that we're done with this, let me briefly go over the activity that we'll be doing in class tomorrow. We're going to play a little game. We're all going to get to try to solve equations together. You'll be put in groups, you'll be given some whiteboards, and you'll be asked to solve equations, step by step, everyone. And the winning team will get prizes. Alright, thanks guys for watching the video. I hope this was helpful. And if we have any questions, we can briefly go over it in the beginning of class tomorrow.